Hey folks, so in this video I want to take a look at Terraform, which is probably the most popular infrastructure as code tool these days. But I think there can be a lot of complexity around infrastructure as code tools for people who are newer to it. So I wanted to explore this and see if we can break it down so it's really quite simple. And so my goal was to simplify it to just the things that you need to know so that everyone can get off to a good start. So to begin with, you'll need some sort of workspace. And I just created this directory here, and so we'll start with a simple example, and we'll go with some more advanced ones as we go along. And you'll start with a file, often called main.tf, but anything extending with .tf will work. And then we get started. So Terraform is written with something called HCL, or HashiCorp Configuration Language, which is a language that HashiCorp, the company behind Terraform, they write for all of their tools. So we'll get to see it. It's a very simple language. It's declarative. So instead of writing anything where you go, do this, and then do this, and then do this, you just tell it what the desired end state is, and it'll take care of figuring out the right order of operations. So before we can actually write any Terraform, one thing we need to do is find what's called a provider. And so this is kind of analogous to plugins in other systems. This is how Terraform's functionality gets extended to support all of these external services like AWS, Google Cloud. In fact, it can do local stuff as well. There's local, there's running Helm against the Kubernetes cluster. You can do all sorts of things. In fact, there's over 4,000 of these providers, most of which are community provided. But there are a whole bunch of both official and partner created as well. So you can do almost anything you could possibly want with Terraform. So I'm thinking for this example, what we'll do to start with is we'll use Docker. That way you can run something locally if you want to follow along, and you don't need any external service. And so we'll pick this cruise worker Docker, and what you'll see here is this page where you'll see a bunch of random stuff. You really don't need to worry about this stuff. What you want is up in the top right, this use provider, and just take this block here, paste it in, and here we go. So there's this Terraform block where we can define the providers that we need. In this case, we're telling it we want that Docker one. And then down below, we can define the Docker provider. And so here we can define the configuration options, as you can see here. But what do we need here? Well, if you have something with autocomplete, you'll be able to see the options available here. I would highly recommend, by the way, setting up your editor to support Terraform. I'm using right now IntelliJ, which has a really good plugin for it. If you're using VS Code or NeoVim, you can do the same. But so the way this works will be you'll set up the provider, and then you'll go to the documentation tab, and you'll just try to find out what exactly is needed for this. So in this case, we can see the main thing we need is the host variable or parameter. And there we go. So in this case, we're telling it, okay, we want to target the local Docker socket. This means that not only can we target the current system, but if we wanted to, we could expose a Docker socket on a different system and target that instead. Okay, so we have that. The next thing we need to do is open your terminal and run Terraform init. And we'll see this is going to run some steps. So initializing the backend, and we'll talk about that in a bit. Initializing provider plugins, and it'll go ahead and figure out all of the providers that are necessary and download them, and it'll install them. And what it means by installing is very similar to what npm does, where it just gets a local directory in your project. And this is something you definitely want to add to your .gitignore. You'll see that it downloads all those requirements. And as we add additional providers, we'll see them all in this directory. And you can see it also creates a lock file, similar to how npm does that, if you're familiar with the Node.js world. Okay, and then what else do we have here? Well, it says Terraform has successfully been initialized, so ready to get started. So then what you want to do is you'll go to your provider's documentation, and over on the left here, we'll see there are two different sections here that you'll find on almost all of them, which will be resources. And this is the types of things that you can create and manage. And then data sources. So these are things that already exist in the system that you want to target. So you might, for instance, have a Docker image that you want to target. In this case, we'll take a look at some of all of this as we move along. And again, this is somewhere where having a nice editor will come in handy. So where I want to start is we're going to spin up a very simple container. What we'll do is we'll come in here and create a resource, and you'll see I've got a bunch of options that are already populating based on the installed providers. And so I want to create a Docker container And I think I'm going to use SonarQube. If we come to Docker Hub, one thing we can look up is an image. So we can say, all right, SonarQube, what do you have? And we'll find one, say like 10.6-community. So we come here and we can say, all right, we can call this SonarQube. So the syntax here is, okay, resource, that's what we're doing. What is the resource? So in this case, Docker container. And then what is the name of this? Not the name in Docker, but the name within Terraform so that we're able to reference it. And then we can tell it the name. And so we could say we want to do SonarQube 10.6-community. And we can call this SonarQube. So that should work. But one thing we can do is we can actually have Terraform automatically manage the pulling and management of our images as well. So we could say, all right, resource, Docker image. We can also call it SonarQube. And we'll just say the name is going to be this. And so now with this image tag, we can just reference, we can say, all right, Docker image dot SonarQube dot, in this case, we want the image ID. You'll notice, this is again where the editor can really come in handy. There are a bunch of different options based on the particular resource type of what we can access about it. So in this case, image ID is available to us. And if we come back, what else do we need? So we probably want to set up a port binding because that's how we'll actually access the container. So what we can do is we can add a ports block. And so we can say internal is going to be 9000, external is going to be 9000. So we're going to map port 9000 on the system side to port 9000 in the container. And then I also want to define what network this is using. I want this to use the bridge network. Network mode is equal to, let's call it bridge. Okay, and with that, again, let's just do a quick review of what we've done. So we've told Terraform which providers to install and which version specifically. We've told it how we want to define this Docker provider. We've defined an image that we want, and then we've defined the container we want created. So with all of that, we can now open up our terminal, and let's take a look at a few different operations that you'll often do. So you can do Terraform format to make sure everything's formatted properly. This is a pretty cool thing that you can do where if you were to have this all tabbed in, it'll automatically save. I have format and save set up, so this automatically gets run every time I save the file. But you'll notice that this makes things with Terraform very consistent. Okay, the next thing you can do is Terraform validate. And you'll see, is this valid? It is, in this case. You can run Terraform plan. And this will show us all of the things that it's going to do. In this case, because everything is new, everything is going to be a create operation. But as we'll see in the future, as we reapply things and we make changes, or if we destroy things, we'll get different operations showing up here. And so plan is just showing us what would happen if we ran this. And so if we run Terraform apply, we'll get the same plan up here, but now we get the option to hit save or to hit run. And we'll see it is pulling the image. This is creating, but that just means pulling. And then it ran the container. So if we do Docker PS, we can see we just spun up this SonarQube container. So now if we open up localhost 9000, you can see SonarQube is starting up. Very cool. So now one thing that's quite useful is if we do Terraform apply again, you'll notice it refreshes the state. So it checks if the environment is still the same. And it, in this case, found that, hey, everything matches. So we don't need to do anything. All right, so here we go. We've got SonarQube up and running. Admin. And we're able to log in. Now this is all nice. But one thing that we're lacking is we don't have a volume set up. So any changes I make are going to get blown away as soon as this container is either killed or restarted. So if we come back here, we can see here is a volume that we should add. In fact, it says 3, but I don't care about the logs or extensions right now. You can just take a look at the data one. So if I grab this path here, opt SonarQube data, what we can do is come back here and we can create a volume, and we can say resource Docker volume, and then we'll say sonar data, and we'll come in here and we'll just call this sonar data. By the way, this command here is just the same as if you were to run Docker volume, what is it, new, create. So it would be effectively the same thing, but in this case, we're defining it as code. And so now I can come in here and I can say volumes, and we'll give it the volume name, which in this case is going to be a reference to Docker volume, and then sonar data, and then we're going to give it the name. And we also need to give it the container path. And so we can say this is going to be opt sonarcube/data. Beautiful. Okay, now if we run this again, look at this. So it's going to say Docker container sonarcube must be replaced. Why must it be replaced? So if we want to figure that out, we can scroll down and we'll see volumes. This forces a replacement. So it's going to have to recreate it. And then we're also going to create the volume. So this plan and the same thing you get with apply can be very helpful for figuring out exactly what's going on in your environment. So let's go ahead and hit yes. And there we go. We now have the new operation, but we can see the old one was destroyed. So now if we come back to sonarcube, refresh, if I try logging in with my new password, so now if we look at this, we can see Docker PS, we can see this was just spun up. And if we do Docker volume ls, we can now see that this Sonar data is available. Okay, the next thing that we might want to grab, because I just magically went to port 9000 on localhost. One thing that's pretty useful that you're going to want to do quite a bit is use this output type. So we can say something like sonarcube URL, and we can craft a value string. We can say HTTP localhost, and we will use a string interpolation, which uses the $sign squiggly brackets. And in this case, we can do Docker container .sonarcube, and we're going to query for the ports, and we'll grab the first port setup. So for something that's an array like ports, where you can have multiple of them, you can access them by their index, and then we're going to say the external address. So you can save that, Terraform apply, and then saying this is going to be the output. In this case, it actually tells us what the output is going to be in advance. That's because it was able to craft it based on the setup here. As we'll see, when you're provisioning new resources, typically this stuff isn't actually known because it'll be dynamically provisioned. There we go. So now get this and could actually grab that directly and access it instead of going to the address manually. So far, everything we've been doing has been Terraform apply, so we're creating or updating things. There's also Terraform destroy, and it'll do kind of the same deal. It'll show us exactly what will be destroyed, which really should be everything. So it's saying, all right, the container, you can also see the image that was pulled, and so it's going to clean up after itself, the volume, all of that will get destroyed. Let's destroy it. And there we go, everything is cleaned up. However, so if we come back here and actually spin it up again, there is one thing that's fairly important to understand. So you notice how this is happening. So the volume, it was able to create on its own, and then in parallel, the image was getting pulled. But notice that the container wasn't able to start until the image was created. And that's because Terraform has a dependency tree. We can actually visualize the dependency tree. If we run this Terraform graph, and we can tell it we want the plan, or we could tell it apply, or whatever we want. But in this case, we'll take a look at the plan. And here we can see the graph that it creates. Not particularly useful in and of itself, but it uses this syntax that we can render with the DOT tool. And so we could say type of PNG, and we're going to output that to graph.png. So now we should have, if we open this graph.png, a very ugly image if I'm being honest. But here we can see we've got our provider, which is this Docker container, or this Docker image rather. And we can see we have the image that depends on it. We also have the Docker volume that depends on that. And then we have the Docker container that depends on both the image and the volume to exist. And so this container won't spin up until both of those have completed, but those can both occur in parallel. And the output relies on that. So that's the whole setup here. So the next thing to take a look at is this terraform.tf state. So if we open this up, this is what actually keeps track of the current setup. So every time the Terraform runs any of the apply commands or destroy, it'll update the Terraform state, which in this case is being stored in this file. And so we can see all the resources that are being managed. So our Docker container is in here, the image is here, the volume is here. And this is something that if you think this is out of sync, perhaps you can run Terraform refresh and it'll update this file. I think the easiest way to prove that is if we do Docker PS, we'll grab the container ID and just say Docker RM, Docker kill EAC, and then Docker RM. There we go. So now this container is totally gone. If I was to do Terraform refresh, we come in here now, we can see we just have the image and the volume. the container is no longer in here. Again, you don't usually need to manually do this. When you run Terraform apply, the very first thing that it'll do is refresh the state. So you don't really need to worry about that, but it is good to know. And you can see it's caught that, hey, SonarQube no longer exists. So go ahead and create that, and we're back. Now, it is quite cool that you can actually just see this here, but this is a bit of a problem as well, because, well, I don't want this to be stored in my system, and you don't really want to git commit this because, I mean, you technically could, but that would mean that every time that Terraform is run, if you're doing it across machines, you need to make sure that you're git committing appropriately and pushing and pulling at the right time. So really not what you want to do. You want to use something called a backend, a remote backend in this case. In this case, we're using the local backend, which is just setting up this file. But what we can do is we can introduce a different backend. All right, so if you come to the Terraform docs and look at the backend blocks, you can see we've got a bunch of different options. So right now, the default one that we're using is local. So you could use any of these remote ones as well. So Terraform does have their own, or HashiCorp, I should say, has their own cloud service where you can integrate directly and it'll talk to that. So you can go to the cloud integration and I think they have a pretty good free tier. So you can give that a try. Typically what I'll do when I'm at work, I'll use like a storage bucket. So if I'm in Google Cloud, I'll be using GCS. If I'm in AWS, I'll use S3. And it essentially manages this same type of state file, but it'll just be on a remote server instead, which works quite nicely. However, for this example, I want to spin up, because this will just be easy, we don't need to depend on any external service. We can spin up a Postgres database and target that. So let's see how this works. So really quickly, I want to create a new file. Just be docker-compose.yaml. Do that at the top level. Okay, and just gonna paste this in. And so what we're doing here is just spinning up a Postgres image, defining a database that we want, in this case Terraform backend, getting a user and pass, and then exposing port 5432 and storing the data. So what we can do is go up a level, docker compose up -d. All right, that is now up and running. Cool. So what we can do now, we don't need to think about this anymore. What we can do is go to our main.tf file, and we can go back up to the Terraform block, and this is where you define the backend. And again, you've got a whole bunch of options. We're going to go with Postgres or PG, and then we're going to define the connection string, which is going to look like this. Postgres, and then username, password, at localhost, port 5432, and then we're telling it we want the database that we created, which is Terraform backend. And then because this is local with no SSL, we'll just say disable SSL mode. So now what we'll need to do is run Terraform init, and what we'll see is, do you want to copy existing state to the new backend? And what we can do is just say yes. And so now everything that was local in this file here now exists in our Postgres database. I can even delete these two files. And if I was to do Terraform plan, we'll see, hey, it still acknowledges the fact that there are no changes. So we are successfully targeting Postgres instead of our local state file. All right, so that's pretty cool. Now let's move on to a more interesting example, because I'm going to be honest with you, SonarQube on a local system, as we saw, there's really not a lot of difference between defining things this way or defining them as a Docker Compose file, if we're to use just Docker as the example. So what we can do is we'll Terraform destroy. We don't need this hanging around, so we'll clean it up. Awesome. But just the joy of infrastructure as code is now, if you ever want this environment again, you can just run Terraform apply and you'll have it up and running in mere moments. Okay, so let's create another example. So the next thing we need to do is find a new provider. So if we come back to the docs, go back to providers, we need to find a different, more exciting provider to work with. Now at your work, you might want to use AWS, Azure, Google Cloud, depending on what your company is using. But I think for personal use, DigitalOcean is a lot nicer to work with because you're not going to have a million different services you need to spin up. And you're not going to be caught paying pennies for the rest of your life because you can't figure out what to clean up. Don't ask me how I know. Okay, so we'll use this DigitalOcean provider. If you don't have DigitalOcean, that's all right. You can just watch. But DigitalOcean is another cloud provider, but it's much more simple. And the billing is a lot more straightforward. A notable thing is their virtual machines are called Droplets. So you'll see that name around. Okay, so what we need to do is say use provider. And we'll grab this, and we'll come back. I'm going to copy this whole directory, this simple directory, and we'll duplicate it, and we'll call this DO, DigitalOcean. Get rid of the graph. And go to the main.tf file, and we can just delete everything else in here. I just wanted to copy that backend over so we can keep using that. And we'll get rid of this Docker provider. So I realized that I've just gotten rid of the block here. So let's just grab this, paste that. We just need the DigitalOcean part. So we'll copy that in, and then beautiful. Except now I want to take a look at one thing we can do, which is we don't need to define everything in the same file. I'm going to rename this file to providers, and then I'll create another separate main.tf. So we'll keep this, but we'll define the providers in this other file, and it'll work beautifully. Another thing we'll do is we'll introduce a variable. So we could say variable, and we can say do token, and so we'll define this as type string, and we will also say that this is sensitive. We don't want this being exposed. And then in the DigitalOcean block here, we can say the only thing we need to define is the token, which is going to be var.do_token. So all of that looks good. By the way, so one thing that you'll notice is when we have these variables set, when we run Terraform apply, first let's switch over to do. When we run Terraform apply or plan or anything, you'll see that it's going to ask us, what is the value for this variable for this run? And in this case, we're going to get an error saying, hey, the lock file is inconsistent because it was expecting us to have the Docker provider. But in this case, we have DigitalOcean. What the heck? So we'll just need to run Terraform init again. Terraform init, and we're looking good. Notice we're still using the remote state. But one thing that is actually important to note, let me actually really quickly to demonstrate something. If we go to the simple Terraform apply, we'll spin that back up. All right, cool. So that's up and running now. So now if I run this Terraform plan, we enter our DO token, it's going to say, hey, so now when we run Terraform init, what's going to happen is we'll see it's using both Docker and DigitalOcean, which is not what we want, because all we care about in the context of this particular project, this DigitalOcean one, is DigitalOcean. We don't want to also be carrying around this Docker provider. And this is where workspaces come in. Also, if I was to do this plan, you'll see that it'll actually try to destroy everything else because we're basically trying to conflict the states of these two different projects. Okay, now we want. So we can do Terraform workspace. Let's see, we've got a few commands here. What we're going to want to do is create a new one, which of course we'll need a name for it. And so we'll just say in this case, do. And so now when we do Terraform plan, no changes, because in this case, we actually don't have anything defined yet. If I was to do init, we'll see it's just using DigitalOcean now. It's not using Docker. So we're in a good spot now. However, notice that it kept bugging us for this DigitalOcean token. So if you are following along, one thing you want to do is go to the API, generate token, and set whatever expiration you want or don't expire. And in this case, I'm just going to give full access. In production, you definitely want to limit these, but there we go. And we're going to copy this, and I'm going to dump this into a .env file. Store that, and we're going to export this as tf_var. And we're going to match the name or extension. Okay, we're going to do this syntax where if we expose an environment variable, which starts with tf_var_ and then the name of whatever the variable was, then it's going to use that automatically. We're not going to have to type it in. Now, of course, this is something you'd absolutely want to keep secret and not expose to the world and have thousands of people take a look at. But of course, I'm going to delete this before the end of the video. Okay, so what we can do is let's just source.env. Now if I run Terraform apply, notice it's not asking me for the variable anymore. So we're all good there. And by the way, one thing we could do is also, if we wanted to, we could actually create a vars.tf, and this way we can keep all of our variables in a single place where it makes sense. Beautiful, and we'll see that everything works exactly the same. Okay, so what do we want to do with DigitalOcean? Well, I think we want to spin up a simple droplet. So what we can do is say a resource, digital, you can see we've got a lot more options here, DigitalOcean_droplet, and then we'll call this just the web. And now, if you're using an editor like this, you'll actually see got some missing properties here. We can just add those to make sure we've got everything we need. So we need an image, we also need a name, and we need to tell it the size. I'm surprised that we actually, I believe, also need the region. this case I'll give this New York City 3. The image, this needs to be, if we take a look, image, either an image ID or slug. And so what we can do with this is introduce the data resource type. So we can say data, and we can say DigitalOcean, what do we want, an image, and we want to go, let's call this Ubuntu, slug, and we'll do Ubuntu 2404 x64. Now how do you even find this? Well, that's something you have to kind of search whenever you spin this up. So that's why it's nice to bake it in here. If I was to go to DigitalOcean and go to Droplets, create a new one, Droplet, you'll notice we've got some options, and you just pick from here, and you can also see there's like sizing info. All of this is the type of stuff that if you run as via command line, you can actually see these exact values, which you might want to use. So pretty nice. That's where you can get that info. But, I might want to use this image for multiple things. So we can, again, do the reference like we did before. But in this case, we're going to reference data, and then DigitalOcean, Ubuntu, and then we're going to give it the slug. So notice how that's subtly different than if you were referencing a resource where you just say DigitalOcean Droplet. But when it's a data resource, you have to prefix it with data dot whatever. Okay, in this case, we'll just call this web. That's fine. And for the size, we will give it S1 vCPU 1 GB. And in fact, one thing we can do is say output going to be droplet IP is what we probably want to call it. Value, and we can say DigitalOcean Droplet .web .IPv4 address. So now Terraform plan, so that will be the output, and we'll create the droplet. So let's apply it. Yes. And now if we go back to DigitalOcean, we go to droplets, we can see, hey, this is actually in the middle of being spun up. And as soon as that's done, which as you can see actually just finished, here's the IP that we can see in the web app. Come here, there we go. It is done, and we can see that that address is the same. So very cool. But as you probably realize, that's just a plain droplet. There's nothing to it. So what I think I want to do is actually make this a bit more interesting. So what I'm going to do is create in this directory Cloud-init.yaml. I'm just going to copy this file over. And what this is a cloud config which will instantiate that, which will run a series of steps that occur on the VM starting up. And so it'll add a user called webmaster. I don't know about you, but I loved back in the day when people were called webmasters. Great title. And so you can see I've done things like added my public key that knows that I can access it or I can SSH in. Added a package, so I want to install Nginx. And here I've added a file that we're going to dump. In this case, it's actually a script, which is going to dynamically grab the host name and get the IP. And then we're going to run that script and then start up Nginx. So pretty simple. Now what we can do is come back in here, and then we can use another data type. This is a kind of unique one, which is called template file. And we can just call this web, what do we call that? Cloud-init file. Just web Cloud-init. And then what we can do is tell it what the template file is. And we're going to use not a string, but we're going to use one of the built-in functions, which is file, and we'll give it a path. Again, we're going to do some string interpolation here because we want to make sure that we're targeting the right file. And so a really handy thing you can do is use this path.module. And so this will always be in the right path regardless of where this exists. And then we'll reference cloud-init.yaml. And one of the things is this is actually, again, a template block. So one of the things we put in here is this source parameter, which again uses that same $ squiggly bracket syntax. I'm defining a variable called source. So if we come back to this main.tf, what I can do is say vars, and we can say source is equal to DigitalOcean. Beautiful. Now under this droplet that we have, we can say, let's use user data, and we're going to target the template file, which is web Cloud-init, and then we're going to do rendered. So now all you need to do is run this again, except this time, again, Terraform is very smart. It'll always identify when there are problems, and we can see inconsistent dependency lock file. That's because template is actually a different provider. So Terraform init, Terraform apply again. So we're going to see that in this case, we're going to have to recreate the droplet because user data has changed. So we'll run it. So notice that it first destroys the old one before it spins up the new one. And there we go. So we can see we now have a new address. So we can grab that. One thing to note is when you use this Cloud-init setup, it actually takes time to run all these steps. So if I run curl this address, we're going to see right now, Nginx isn't even up and available. So I'm going to have to wait just a moment before we resume. So there we go. We can see that this is working. And if I was to go into the browser, hello from DigitalOcean. So that's what we've got so far. So let's introduce a few new things here. So first, let's say that we want to have multiple replicas. So we can add something called count. So we can say, all right, we want 2 replicas. And now what we can do is we can add this block here, and we can say count.index. And so now instead of having just web, we're going to have web 0 and web 1. And to make this a bit more interesting, we can actually add a load balancer between these. So we can say DigitalOcean load balancer, and we will give it a name like public. And inside DigitalOcean, we'll call this, say, WebLB, and the region will be New York City 3. Okay, this is where it gets fun. So we can go to forwarding rule, and entry port is going to be 80. Entry protocol is going to be HTTP. Target port is going to be 80. Target protocol is also going to be HTTP. Now, you probably want to actually set up HTTPS, but that is beyond the scope of this video. Okay, but how do we actually target this? Well, we can say droplet IDs, and you can see here it expects a set of numbers. So instead of actually creating a set, what we can do is just target DigitalOcean droplet, and we can say web, but as we saw previously, when we have a set, we can actually specify an index, or in this case, we're going to say asterisk or all, and then we're going to give it the ID and not do that. There we go. So what this will do is run Terraform apply. Oh, and you can see I made a mistake here. So down here in the output, we also need to add the asterisk there, which also we should probably create a load balancer IP endpoint or output and say equals DigitalOcean load balancer dot public dot, what is this, public, what is it, just, I think it's IP. There we go. Okay, now Terraform apply. So what is it going to do? It doesn't need to create a new droplet for the existing one, so it's just going to rename it to 0, but it will create a new droplet, a second one, and it's going to create a load balancer. So apply it, and you can see how smart it is. So it saw that it went from a single instance to a set, and now we can see it's still keeping that output, but we'll only know the additional one after it's been created. And there we have it. So we now have the new droplet IP and the load balancer IP. Also notice that the load balancer took almost 3 minutes to provision, whereas the droplet was just 30 seconds. So there is not a lot of consistency across all the different resource types because everything takes however much time it takes. If you're in like Google Cloud and you try to provision a Kubernetes cluster, you'll notice it takes like 10-15 minutes sometimes. Okay, actually I wanted to see that IP. What you can do is you can say Terraform outputs, output rather, and we can get that. Or if I just want the specific one, I can say load balancer IP. Grab that. There we go. So if I hit this, you'll see it's bouncing back and forth between web and web 1. If you're wondering why it's web and not web-0, that's just because the script that initialized the hostname ran before we updated the name. So that's how that works. By the way, so here we were using count, but that's not always the approach that you want. Sometimes you want some actually more useful identifying information than just a number. And so there's this for each syntax as well, where you can create either a map of data or just a set. And we can try that. We could say for each, we're going to say to set, and we're going to say, let's say north. So all the directions, and we can just say each dot key. Now, if we had a map instead, we could also use values. I think we have to change some of these references. So we're just going to keep with count for now, because it's just simpler. The last thing I want to look at with this example is introducing something called locals. And so locals are just essentially setting local variables for this particular setup. These are things that aren't variables. You could use variables to generate strings based on variables, but here I'm just going to set New York City 3 as the region, and I'm going to set some sizes, which this could be a map, and I'm going to say small is going to be the S1 vCPU -1 GB. And you could fill in medium, whatever I want. I should just leave it at that. But now we can come to anywhere that we use this. Of course, this is more relevant when you have more than a single instance. We can say local.region, local.sizes.small. And so instead of having to redefine things over and over again, you can set them up here. And again, these can be composed based on other path.module. You can create whatever you need to do in here. But if I was to Terraform apply, you can see it is the same. It reads this identically. All right, so just a quick summation of this example. So we've just looked at locals literally just now, which are variables for this setup. We've got our data sources where we can extract information from remote systems, things that we ourselves haven't provisioned, at least not in this particular setup. We also have the template file, which can be incredibly useful for scenarios like this, where you have some file that you want to run locally, but you want to update some values. And we had our resource blocks, but we were using account to provision this multiple times or multiple instances. We're referencing data in a slightly different way. It's similarly with locals. Unlike the resources, we actually have to append the specific thing that we're referencing. And we've looked at grabbing from a list of items. That's pretty good. Now I'm going to go ahead and clean this up so I'm not keeping all this junk around. Next up, we're going to take a look at a more advanced example where we're going to introduce something called modules. And in order to do this, we'll just create another directory here. We can copy this DigitalOcean one. We'll call it Kates or Kubernetes. And so we can just delete most of this stuff. We don't need the Cloud-init. Basically all I want is the providers, which would be this, and the variable, because we're going to keep using DigitalOcean for this. Okay, so the other thing we want to do, let's navigate to that directory. And really quickly, we'll just quickly switch our workspace. So Terraform workspace, new, Kates. So now if we take a look, Terraform workspace list, we can see we had the original one we started with, DigitalOcean one, and now Kubernetes. So what we're going to do is we're going to build out what are called modules. So if we create a new directory called modules, it doesn't actually need to be called modules, but it makes sense because that's what we're building here. And I'm going to create one called cluster. And within that, we'll create a main.tf file. And so what we're going to do is in this module, we'll build out the way to provision a cluster in a reusable way. So this isn't specific to just this one particular setup. This is for any time we want to provision clusters. So we can reuse these modules over and over again. So to begin with, we need to come back here and we'll use this provider again. But here's the cool part about modules is that we don't need to set up the provider DigitalOcean. We don't do that here. It actually gets passed by whoever calls the module. We just tell it the providers that it's going to use. So in this case, DigitalOcean. So now we can come to the DigitalOcean provider, check out resources, and we can actually filter this on Kubernetes cluster, and we can just see an example here. We want one that auto-scales, so we can just grab that, paste it, format that nicely, and we'll just call this main. And we probably want to make this a variable. So it's a variable cluster name, and we could say type of string. We can even add a default if we wanted, and just say my cluster, and then we can just say var.cluster name. Again, we might want to add a variable for let's call that cluster region. Actually, no, region type string. Default is going to be New York City 3. Now, one question that you should always have in mind when you're creating a module like this is how much of this should actually be parameterized. Because theoretically, I could just turn each and every one of these into a parameter. But the thing is, if I've done that, then what's the point in not just using this resource wherever I'm calling this module from? The idea is you want to provide a smaller interface, and you're providing something that's pre-canned in exactly the way that you want. So I think we'll leave it at that for now. And for the version, we can come in here, and I think the best way to do this is if we come to DigitalOcean, create a Kubernetes cluster, you can see here's the version that we want. Okay, and let's just turn that down to a max of 3 nodes. If we want, we can also add some other things like a maintenance policy. We could say start time is going to be at, let's say, 2 a.m. on, what do we want, Sunday. And so now we have a module that we can use to provision the Kubernetes cluster. So the last thing we're going to want to do here is set up some output variables, because we're going to want to be able to talk to the cluster. So we'll say output, and this is going to be cluster data, and the value, we'll actually do something different here. So previously we were just using strings. We can do an output map, and we're going to call this first the host, which is going to be DigitalOcean Kubernetes cluster.main.endpoint. We'll say token is going to be equal to that.that.kubeconfig. Grab the first item, and then we're going to get the token, and then we're going to get the cluster CA certificate. It's going to be equal to base 64 decoding. Again, this is just one of the helper functions built into Terraform. We're going to grab the cluster main kubeconfig 0.cluster CA certificate. Beautiful. And this is sensitive, so we'll set that to be so. All right, so what this set here is essentially giving us what we need to be able to communicate to the cluster, as we'll see in a moment. So now if we want to use this, we can come back to our main.tf file in the modules, or in the top level, rather. So now at the top level, we can say module, and we can call it whatever we want. This part doesn't really matter. This is just like a name, just like anything else, so it's just a reference. Given the source, we can do modules and cluster. And we're going to need to give it the cluster name, which in this case we can call my amazing cluster. And I think we also gave it the region, which we had a default for, so we don't need to set it, but we can. And we'll see it's complaining about a missing property. I think that's just the editor's not quite caught up yet. So if I do Terraform init, there we go. It now knows that it's inheriting the provider that we set at this level. Okay, the next thing that we might want to do is actually set up something inside of the cluster, like let's say the Nginx ingress controller. So we can create a new module. Again, it's just a directory, and in this case, let's just say ingress main.tf. And this time we're going to use some different providers. So if we come back to the docs here, we're going to want the Kubernetes provider. So we'll grab that, paste it, and we're also going to want the Helm provider. Just need the inner block. There we go. So that's good. And before we forget, let's grab this, come back to our top level providers, and we'll reference that as well. And now we'll need to define these providers for this setup here. So say provider, Kubernetes, and we'll do provider Helm. Inside of this, there's going to be Kubernetes, and we're going to say host. It's going to be module.cluster. This is how we're referencing the output of the module, this cluster module here. And we're going to say cluster data.host. Token is going to be module cluster data.token. And then we're going to have cluster CA certificate is going to be equal to module.cluster.cluster CA certificate. Beautiful. And if we go back to the Kubernetes one, it is just slightly different. Go to the documentation. All right, and for the Kubernetes one, we're going to do something almost identical to these, but I believe the host in this case needs to start with HTTPS. Okay, so that looks good. And so now we're able to use this when we call to this module here. So what we can do is we can now go to Artifact Hub. So this is a great place to find Helm charts for Kubernetes. So if I look up ingress Nginx, just grab this first one here. This is the official one, so this is what we want. And I'm going to grab this. So we'll come back and we'll say resource, Helm release, ingress Nginx. Chart is going to be ingress Nginx. We're going to say the repository is going to be this, with the name of ingress Nginx, and we'll put it in the namespace of ingress Nginx. We'll create namespace true. By the way, if you don't know Kubernetes, don't worry. We're not going to dive too deep into all of this. We're just going to use this as a quick example. And if you're familiar with Helm, you'll know that there are two different ways to set values. So there's a values file that you can pass in, or you can use set commands. And so if we use something like this, we can say for the set, we can do, I know there's this ingress class resource dot default. So we can grab this, paste it in here, and we can set this to true. Okay, and that'll now pass that value to Helm when it runs it. So that looks good. And now one thing we might actually want to do, now that I'm thinking about it, we should probably grab DigitalOcean as well, because we can set a DNS record for this ingress controller. So we can do this, and then we can add in now a data Kubernetes service. And we're going to call this just the Nginx ingress Nginx. And so what we're doing here is we're referencing the service that we're creating with the Helm instance. So I just happen to know this based on having used it. This is something you'd have to experiment with, but the name of this is going to be helm release.ingress.nginx.name, and then it's going to be controller. So that's the service that's going to be created, and the namespace is going to be ingress nginx. But in fact, one thing we can do that's better than this is we could say helm release.ingress.nginx.namespace, and that way we don't need to update that value in two places. And one thing we could do, we don't need to, because we're directly referencing it, but one thing that comes in handy quite a lot, or in fact is necessary to make sure that the right order of operations occurs, is you can use this depends on block, where you can say, all right, this needs the ingress nginx helm release to complete before this runs. So in this case, we might not actually need this since we're referencing it, and often it'll create the right dependency chart. Now let's come back here and we'll go to DigitalOcean, cover the documentation. Okay, so we'll come down to this DigitalOcean record. And so what we're going to want to do is create an A record. And so what we want to do is just copy one of these, come back here. First we'll do data, DigitalOcean domain, DigitalOcean domain. And then here we can say DigitalOcean domain, main.o. Say data.digitaloceandomain.main.name.id. In the A record, we'll set this to be a variable. Actually set these both to be variable. So we'll say variable base domain is going to be type string, default be the domain that I have, and then we'll say subdomain. And this will just be, it'll actually sit in a default. And so here we'll switch this to use var.basedomain. And then here we'll set var.subdomain. And the value of this is going to be this, the Kubernetes service. So it'll be data.kubernetesservice.ingress.nginx. This is a bit of a fun one. So it's going to be status.0.load-balancer.0.ingress.0.ip. And you'll even see that the editor is complaining because it has no idea what is so deeply nested, but this should be correct. Come back here, we can say module ingress, modules ingress. And then we need to pass in the base domain, eltonly.com, subdomain, call it demo. And is that all we needed? Let's go ahead and do Terraform init. Beautiful. Okay, so now we have all of this. Let's go ahead and do Terraform plan. Oops. Of course, what I want to do is source the .env file I had earlier, because recall, I created this that has the DigitalOcean token using tf_var_ the variable name we're using. So I'm going to do that. Let's come back here, source it, Terraform plan. So we'll see it will create the cluster, it will look at the ingress, it will create the DNS record, and it will spin up the item. Another thing we can do if we want to do this again is we can do the Terraform graph. So we can see this has gotten significantly more complicated because we're using different modules, but the same idea still applies. Okay, let's not look at that anymore. Let's go ahead and run it. Now this one will take a little while because spinning up a Kubernetes cluster typically takes, 5 to 10 minutes, somewhere in that ballpark. All right, quick catch. I had the HTTPS on here before. Turns out that is not needed. I think I needed that for GKE on Google Cloud, but not with DigitalOcean. So that was causing an error. So now this should do the trick. So I'm applying it again, and there we go. All right, so now if we go to DigitalOcean, we can see we now have our load balancer that we have set up. If I go to the domain, we can see that demo goes to that address. So that all looks good. Of course, if we go to demo.eldonley.com, we're just going to get a 404 because we actually don't have any resources set up. Okay, so now what we can do is we can provision some sort of application. So if we go to Artifact Hub, browse packages, and we can find something that looks interesting. How about Grafana? Grafana is, I think, fairly easy to install. Now the question is Grafana something we want to install a bunch of times, or is it going to be just this one-off? And so if it was going to be something we'd use a lot, we could set up a module for it if we wanted to. In this case, Just to spice things up, let's do it inline here, where we can set up a resource, Helm release, and we'll say Grafana. Okay, so we're off to a good start. Now let's take a look at, in Artifact Hub, let's take a look at the ingress and make sure that we enable it. True. And the ingress.hosts. Clean that up. And we'll get the first one, and we'll set this to the demo.eldonley.com in this case. What we can do is we can add a locals, and we can just paste this up. So we don't need to define this twice, right? So we can update this and say local.base domain, local.subdomain. And then down here, we can compose this by saying local.subdomain.local.base domain. So now if we apply this, it will spin up Grafana. All right, so check it out. So go to my URL here. It is now up and running. Okay, so let's do a quick recap of everything we've taken a look at so far. So in our simple example, we started with a basic Docker provider so we can run things locally. And we took a look at resources. We took a look at referencing other objects. And we took a look at outputs. Then when we moved on to the DigitalOcean one, we saw how we can introduce both local variables and other variables like this, and how we can use environment variables to feed into these. We looked at how we can use multiple files, how we can read in other files like this Cloud-init file as a template, how we can introduce things like the count and the for each. And then we've moved on to the Kubernetes section where we've now looked at breaking things into modules. And so one thing to note is with the modules, and one thing I haven't touched on is with the modules, you actually don't need to reference something locally. You can reference something in a different repository. So you could say my org, my repo, and then you do /, and then you could say the modules path, and then say cluster. And if you wanted to, you could even add in a ref and say my branch, and that would work exactly the same. It would pull it locally, and it would work just like as if it was local. Because as we saw before in the .terraform directory, which again you want to git ignore, that will pull the providers and the modules into this local path. So that would all work just the same. And so the last thing I want to discuss is what exactly can you do with Terraform? So we've seen some simple examples and we've increased a little bit in complexity, but what I think is worth exploring is the fact that you can do a whole lot with Terraform. So of course, if you're using one of the big three, you can use those. And if you go into any of these, you're going to see there are about 1 million different things that you can do with these. It just goes on and on and on. And so anything you can do in the UI with those tools or with their CLIs, you can do with this as well. But you can do all sorts of cool stuff. Look, you can manage Salesforce with Terraform. You can manage your Backblaze buckets with Terraform. You can manage Artifactory, Splunk, all sorts of things. Hell, check this out. Someone has even created a Spotify integration so you can manage your Spotify playlists using Terraform. If you're into the home lab scene, you can use a Proxmox provider, or you can just use, libvirt. Again, you'll notice a lot of these are community created. They aren't official. And so you need to figure out what the right one is and experiment. You can even build your own providers if you want. It's just a matter of figuring out exactly what you want to do. So really the approach that I think makes the most sense is first, figure out exactly what you are trying to manage, and then see if it is a provider. And then explore the providers and see if any of them fit the bill. From there, figure out which things. Once you figure out what you want to manage, then you want to figure out, are these things that you're likely to reuse over and over again? So should they be put into a module? Or are they things that are just for this specific setup? In which case you can just define it as a inline resource. Though you can still use modules to break things down as the project gets large. But I think you really have the balance of, do I want to use files? You can break things into multiple files, like main.tf is just kind of a convention. You could have each individual resource broken into a separate file if you wanted to. That would make things more complex to work with, but you could. And so, it's just up to you based on what makes the most sense. I think we should probably go ahead and destroy this. There we go. All cleaned up. So that's kind of the main things that you need to know about Terraform. So I hope this has been helpful, and I will catch you in the next one.